Good afternoon to everyone. This is Dr. B. Polaiah, working as a professor in the Department of IT, Institute of Aeronautical Engineering, Hyderabad. I'm very glad to inform you that the image processing is not only concentrating on a simple theory concepts, but it also concentrated on problem solving. So, which based on the theory concepts which we already discussed earlier. So let me start now to understand such a problem solving, how this image processing will be useful. So first of all, I am taking one of the topic which is problem solving on arithmetic coding. Okay, so this is actually a simple concept. The related where we are applying such a arithmetic coding, the concept which we discussed about image compression. Okay, so the image compression is actually is a process applied to a graphics file to minimize its size in bytes without degrading image quality below an acceptable threshold. So by reducing the file size, more images can be stored in a given amount of disk or memory space. That is what we are simply concentrating in aspect of the most common compression method, which we call as JPEG, tends to blur the appearance of lines, especially at low resolution. And coming to the in contrast, lossless image compression techniques retain the original quality, but do not compress the images as efficiently. For example, including TIFF, GIF, and PNG formatted of the image, which we are going to be applied in terms of original quality. So, if suppose there are two types of image file compression algorithms, which we are already discussed about these two. Number one, lossless compression. Number two, lossy compression. Number one, lossless compression algorithms reduce the file size while preserving a perfect copy of the original uncompressed image. So lossless compression generally, but not always, results in larger files than lossy compression. So with both are very common in use. As an example of lossless compression is zip archive files, and an example of lossy compression is JPEG image files. So based on these two important, we are going to concentrating on in terms of data compression methods. So what are those two different data compression methods? Number one is, of course, lossless method will be going to use. Number two will be lossy methods. So lossless methods, which we may concentrate on text or program. Lossy methods, which we are considering in terms of files where we call image files, video, or audio files. So here, in case of lossless methods, the text or program which we are keeping in terms of lossless method, which we are running in classification of run length, and Hoffman and Limfill. This is one of the text or program lossless method. Okay, so these methods are very important. Whereas in lossy methods, image, video, audio based, we are processing in terms of a format, that is JPEG is one method, and MPEG is one more method, and MP3 is the one more method. As you all of you know about this JPEG, MPG, and MP3 videos. Okay, so based on these classifications, which we are going to be concentrating on, the data compression techniques also we can be improved. So here, based on the data quality, based on coding schemes, based on data type, based on applications, we may going to be classified in detail. So far, we are concentrating on either lossless compression method or lossy compression method, which are coming under the data quality methods. So whereas based on the coding schemes, we are going to be concentrating, that is number one, Huffman coding and arithmetic coding, which we are concentrating on today. Okay, so discovery based coding, that is LZ77, LZW, LZ78. So or borrows Wheeler transform, run length encoding, and scalar and vector quantization, wavelet transformation. Okay, EZW, SVHIT, these are. So based on data type, the text compression, image compression, audio compression, video compression, these all are based on the data type. Based on the application, wireless sensor network, medical imaging, specific application, we are going to be concentrate the data compression techniques. Okay, so where we can also concentrate the data compression. Lossy algorithms compress the data while losing some details. They reduce the number of bits used to represent the message, even if that reduces the quality of reconstructed data. So lossless algorithms reconstruct original data without any loss. Because of this, they use a higher number of bits compared to lossy algorithms. So we are today concentrating on arithmetic code, which is arithmetic annealing. Arithmetic encoding is a lossless algorithm that uses a low number of bits to compress the data. So this AE means arithmetic encoding algorithms reduces the number of bits, is the AE encodes. AE encodes the entire message using single number between 0 and 1. So each symbol in this message takes a subinterval in the 0 to 1 interval corresponding to its probability. To calculate that probability, it's not that much of easy, because in between 0 to 1 intervals there are number of values will be vary. But we concentrate that value finding in terms of probability, in terms of a frequency table should be given as an input to the algorithm. This table maps each character to its frequency. That is, the more frequent the symbol, the lower number of bits it is assigned. As a result, the total number of bits representing the total number of bits representing entire message is reduced. So this is compared to using a fixed number of bits for all symbols in the message, where we called as Huffman coding. So coming to the such a Huffman coding simple examples which we can concentrate. Example number one. Assume the message to be encoded consists of just three symbols, which we named as A, B, C. So by analyzing some previous messages, we get the frequencies of the three symbols in terms of A equal to 2 times, and B equal to 7, and C equal to 1. Using this frequency table, we can calculate the probability of occurrence of each symbol at A equal to 2, B equal to 7, and C equal to 1, which based on the probability formula. What is this probability is calculating as follows: by the help of frequency of the symbol divided by, this is the formula, by the frequency of the symbol divided by sum of the frequency of all symbols, is nothing but your frequency table. Here the probabilities of our three symbols based on this formula will calculate it. Probability of A, we going to have that frequency of the symbol is 2 is given here, and divided by sum of the frequencies value. Sum of the frequency value is 10. So what is the value we'll get? 0.2. And probability of B is given, that is frequency of symbol is 7, and sum of the frequencies of all symbols is 10, and it will going to get your 0.7. So that is 7 by 10. Whereas the next probability of C, that is third symbol, the value we given as a frequency of the symbol is 1, and sum of the all the frequencies of the symbols are 10, then it will get the 0.1. So given the message that the probability table enable encoding, can start encoding process. So that is encoding in enabling encoding works by representing the cumulative probabilities of all the symbols on a line that ranges from 0 to 1. On that same line, each symbol uses a subrange. So given any symbol C, it starts from the value and ends at the value calculated using following equation. So that is, you have C is here, and you know the value of range 0 to 1, and you know the value of the S, which is the value of S ends at the value of calculation. So where we simply calculated each one is S is the cumulative sum of all previous probabilities. P of C, that is probability of symbol C. The range of line, which is calculated by subtracting start from the end of the line R. Let me see that line in terms of how it is beginning and ending. In the beginning, the line starts from 0, ends at 1. That is the R equal to 1. This is clear. Let's calculate the start and end of the values of three symbols A, B, C. That for the first symbol A, it starts from 0 to 0 point, that is first value 0 plus 0.2 into 1.0. That is, you have the formula. According to this, we submitted the values and we'll get the start value 0 because it's the first symbol. The range is 0 to 2, 0 to 2, 0 to 2. At 0 instant, your range of the line starts of probability value is 0.2. For the second symbol B, starts at 0.2 to 0.2 plus your 0.7 into 0.1, which is your calculated earlier values. Then the range is starting at a line 0.2, ended of the line will be 0.9, then the ratio will be 0.2 to 0.2 to 0.9. Where third symbol, if you goes to C, starts from 0.9, which you have calculated, to 0.9 plus 0.1 into 0.1, then we'll get to 1. So this is 0.9 and 0.1 is the range, that is 0.9 to 0.1. So what do you mean to understand here? 0.9 to 1 is the last part of the line of the symbol. Given the range of all symbols, it's good to represent them graphically for the following figure. Following figure. Let me see that following figure is here. Starting value will be 0. Then A ended with 0.2, and B started with 0.2 and ended with 0.9. C started 0.9 and ended 1.0. So here I observed that the first one is the first symbol starts from the same start point of the line 0.0, and the last symbol ends at the ends of the line 1.0. A symbol C covers the percentage of the range that corresponding to its probability. For example, the symbol B covers 70% of the line because its probability is 0.7. Okay. And let us we have one simple diagram to consider as example number 2 under the static arithmetic coding, which is here. Let me to read that example 2 of the problem. Consider an of open interval, that is low to low comma I. Initially interval is set to 0 1, and the range will be low high to low, that we simply say as I we consider 1 and low consider 0, then the value will become 1. Interval is divided into cumulative probabilities of n symbols as we discussed in earlier example. Then n equal to will become 3. So probability of A, that is at first symbol A, is 1 by 2, because 2 is the your some of the frequencies of the symbols changes according to given problem, 1 by 2, and probability of B equal to 1 by 4, and probability of C will be 1 by 4. So based on these all the values, we can now see the your any value in the range of how it encodes that BCCA, this line, this is the line, okay. As for your values, so B will be started from here, and next will goes to C, and next will go to A. Where is the A? He is here. Next will go to A, and that is A. He is here. So that is the your part. So here B. So B will be here. Starting will be here. End will be here. And next C start will be here. End will be here. That is here. And C again starts here and ended here. And whereas A will be start and end. So what is this values are varying in between based on the your frequencies of the symbols. Similarly, we'll going to consider other type of other numbers which we consider under the adaptive arithmetic code. This is arithmetic code, adaptive arithmetic code. Previous one is static arithmetic coding. Okay, sorry. Previous one is static arithmetic coding example, where we right now concentrating on adaptive arithmetic code. Okay, so let me to read the example 3 under the arithmetic coding. Consider an half open interval low to high, that is reverse. So initially interval is set 0 comma 1. So and range will be low to high. So 1 to 0 will be 1. Interval is divided into cumulative probabilities of n symbols, each having the same. So based on this, n value will be 3, because 3 symbols are given. Okay. So number of symbols are 3 only. 3 only. So n will be value is 3. At first one is be 1 by 3. 1 by 3. Next 1 by 4. 2 by 4, second one. Next third one will be like that. Third one, C symbol, 3 by 6. So what is this? The any value range in between that encodes only B, C, C, A, B, C, C, A, B, C, C, A is the your range how it is varies. Okay. Next, static zero order model is used in the first example, dynamic. Nothing but a second example, update it's more accurate. Initially we have a frequency distribution, but every time we process a new symbol, update the frequency distribution, which we observed from the static arithmetic coding, arithmetic encoding. So let us we see that the practice of arithmetic coding, which we are following for the solving of simple problems. The first one is the dynamic version is not more than more complex than the static version. The next one point is the algorithm allocates logify number of bits to a symbol of probability phi, whether or not this value will be is a low or high. So unlike Hoffman codes, which is a fixed to variable coding scheme, arithmetic coding is variable to fixed coding scheme and is capable of allocating non-integral number of bits to the symbols. So producing a near optimal coding, it is not absolutely optimal due to limited precision arithmetic operations. Incremental transmission of bits are possible, avoiding working with higher and higher precision numbers. So the two main parts in the arithmetic coding, which we are concentrating in, number one will be updated frequency distribution. Number two will be update subinterval Z. Initially, we have the interval low, L will be low, and H will be high, R will be range. L plus R will be range, that is 0, 1. The symbols of the alphabet are mapped to the intervals in terms of 1 to so on S to N. For each incoming symbols S, the intervals is updated as L low will be L equal to L plus R into summation J equal to 1 to S minus 1, that is P of J. That is probability of J. That J value will be 1 to 1 to 1 to S minus 1. So the range will be R equal to R into P of S. That is P of S is your statistical value which you are enabling. So coming to the example number 4, in between the relationship of a symbol, probability value and range. As we calculated ABC, according to the ABC line, the symbols and range we calculated based on the given data in the problem, and we extended the same to understand about range values or varies, whereas A is the probability value which we calculated 0.2. According to that line of the frequency values, how it is changes in between 0 to 0.2. Similarly, 0.1 will be in between 0.2 to 0.3. 0.2 will be 0.3 in between 0.5. That is a range. 0.05, that is a D bit, D value. So in between this we extended from here. For 0.2 will be added here. Next 0.3 will be here added, then we'll get the range. Next 0.05 added, and then we'll get this 0.9. And 0.1 added to here, then this will be 0.9 will become 1. So that is the range how this will be changes. Why we stopped to 1? Because our frequency values of the symbols are varies in between 0 to 1, or we consider 0, 1. So according to that theory, we stopped here to understanding and analyzing about example number 4. So the value which we consider here and output of the symbol C have the low will be 0.3, high will be 0.45. What is this? This is the range of the C. This is the C range. This is C range, you see. This is C range. So according to that range will be 0.2. So similarly, A will be here and 0.2 will come, and this is the value given of E, and we'll get the range 0.3. 0.8 will be here, that is slight changes, which will 0.3, and range will be in between that. Even small changes also, nothing is changes. E will be 0.3 as 0.3 only. Dollar symbol value as final value will be 1. So example number 5, imagine a binary sequence where A equal to 3 by 4, B equal to 1 by 4. Compute the arithmetic code of the sequence A, B, A, comma, AB, BA, BA and BB. So here we got that the range of values which are varying up to 4. So 0, 1, 2, 4. These are the values are varying according to the binary. Okay, this is 0, this is 1, the range, and this will be 0. So according to these ranges, that is AA, so how this AA will be changes? It changes only in between two values, 0, 0, 0, 0, 1, 1, 1, 0 is 2, 1, 1 is 3. So maximum value will vary here is 1. And whereas we extended 3, 1 triple 0 is 3, and 2 No, sorry, 0, 1, 2. That is 0, 1, 0, 1, 2, 4. 0, 1, 2, 4. So what will be here? This is actually we want to change 1, 2, 4, 6 length. 4. So based on that values or changes, then we'll get the 0, 1. This is 2. This is 0. Okay, 0. Next, this is 3. This is 4 plus 4, 2, 6. This is 7. So according to your range of values will be achieved. 7. So arithmetic coding encode symbols. Let me take this is one line symbol CAEE dollar. A is the probability distribution of the symbol. B will be the graphical display, shrinking ranges, and C will be new, low, high, and range generated. So taking the table, symbol, probability range is given. So according to this, we'll start drawing your symbolical symbols. Your given example is CAEE dollar. CAEE dollars. Yes. So this is the dollar. So your C, where is the C? You are started, and A will be started from here, and E will be started from here, E, and your symbols. So you achieved your arithmetic encoding process. So according to your achieving your symbol, low, high, and range values, how it is varies according to the we discussed the previous example. The encoding process is illustrated in the above figures of H and C, in the which a string of symbol CAEE dollar is encoded. Initially, low nothing but 0, high nothing but 1, and range will be in between 0 to 1 is nothing but 1. After the first symbol C, range below C is 0.3, range M high, that is MGH of C is equal to 0.5. So low is 0.0 plus 1 into 0.3 will get 0.3. High will be 0 to 1 into 0.5 will get 0.5. The new range is now reduced to 0.2. So for clarity of illustration, the even sinking ranges are enlarged in each step in the figure shown. After the second symbol A, low, high, and range are 0.3, 0.3 or under 0.04. So the process repeats itself until after terminating the symbol dollar is received. So by the low and high are 0.33184 is low and 0.33220 is high respectively. It is apparent that the final we have range PC, PA, PE, PVE, PS, that is the range all the submit, then we'll get your required value. The final step is in encoding, calls are generated of a number of that falls within the range low to high is nothing but 0, 1. Although it is trivial to pick such a number of decimal is here according to the ranges 0.333184, 0.33185 or 0.332. In the above example, it is less obvious how to do it with a binary fractional number. So with these examples, I want to close which we are discussing about arithmetic coding based on the concept of compression, image compression, which we are classified into two types. One is loss compression, lossy, second one lossy compression. Based on those two, we have discussed the best examples as 1 to 5. I am very thankful for your listen on understanding about these problems, and we'll continue the problem solving in coming class with other examples also. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.